Well, good night and good morning to my TT Lab family and to my team. It's a pleasure to introduce everyone here to my teammates, Aishatu Guadabe, Jonas Izanega, and Irfan Mansouri. My teammates come from regions all across the world, Aishatu from Germany, Jonas from Switzerland, and Irfan from India. I would really love to extend my thanks to them for taking time out of their busy schedules to accompany me tonight and spread awareness on our project. I would like to also welcome Torian Dyer as our mentor tonight. One of our members, Bijal Mehta, was unable to make it, but we would also like to acknowledge her contribution to the project. In the criminal justice system, courts are currently partnering with AI risk assessment tools for risk management and assessing recidivism. However, the use of proprietary predictive algorithms exacerbates the inequities within the criminal justice system, and it further criminalizes the BIPOC communities as they lead to decisions that may violate due process or that may discriminate based on race and gender. AI algorithms can directly influence assessments, procedures, and decisions in the criminal justice system.
My name is Aisha too, and it is with great pleasure and pride that we present to you our solution to the challenge AI in the criminal justice system, part of the Ethics for Next Gen AI Hackathon 2020 and hosted by Data Ethics for All. We have developed a hybrid solution which takes the form of a web application called Gavel 2.0. We closely examined the Compass algorithm, a widely popular commercial AI risk assessment tool, which uses proprietary predictive algorithm. Compass is used by judges for scoring a criminal defendant's likelihood of recidivism. The algorithm has since been placed under much scrutiny because of its biased results. This bias not only emulates the sentiments of a racist judge, but it has also already done its damage by villainizing certain racial groups in the system, as well as failing to give a proper score for those who may be an actual threat to society. Unfortunately, this algorithm exacerbates the inequities within the criminal justice system and further criminalizes BIPOC communities. We identified several problems. First and foremost, the Compass risk assessment tool is unfair. As we will show you during our presentation, the Compass algorithm is 2.14 times more likely to erroneously score African Americans as future recidivists when compared to Caucasians. Secondly, a recurrent concern about machine learning algorithms is that they operate as black boxes, making it difficult to identify how and why the algorithms reach particular decisions, recommendations, or predictions. Yet judges rely on these algorithms with increasing frequency. They accept the proposed algorithmic decision unquestionably. This poses a problem of accountability, especially when it comes to verifying legal decisions or results. Lastly, there's the lack of transparency and accountability. Compass shows the judges only a final risk score. When people's lives are at stake, AI should not be blindly trusted as the sole decision maker, but must remain in the role of a decision support in the human machine relationship. So we asked ourselves, what do judges need to see to quickly change their minds concerning the Compass score? Our algorithm is designed with the principles of explainable AI in mind by showing the discrepancy of the Compass score between the different races. Our solution offers the judges a normalized score, presenting a racially unbiased score in comparison to the Compass score and how the individual should have been treated differently to ensure fairness. With our solution, we want to challenge the decisions made by AI and raise awareness among the judges to use these algorithms responsibly and as a tool only. AI in the criminal justice system should never be the sole decision maker. Responsibility and accountability for decision making must remain with the judges.
Thank you, Aisha, too. Jonas?
Yes, so thank you, Aisha, too. Before we jump into the demo, I'm going to present you a bit like what's actually wrong with the algorithm and what we did to solve it or try to reduce the bias.
So you can share
I
your
am
screen
presenting
now?
my screen now?
Yes.
No. So do you see my full presentation, my Google Doc?
Yeah.
Okay.
What
Good.
you have to click share screen.
Ah, okay.
Yeah, it's a green icon.
Good. So now you see my
Now
amazing.
I see yes.
Yes. Okay. So as Aisha too mentioned, the main problem with the Compass algorithm is that it's biased in terms of who suffered the harm of the error. So what you see here is the false positive rates by the different races. So as you can see, well, first the false positive rate for those who don't know is the proportion of people who are wrongly identified as future recidivists while they're not. So as you can expect, this can, like if you wrongly identify as a future recidivist, this is going to impact your life. So as you can see, African American and Native American are the ones that really suffer the harm of the error here. So in order to understand how can we solve it, we first try to replicate the algorithm. So for this, we use some gradient boosting model with the explanatory variable that we had access to. So we had about 10 variable and we removed race and gender. Just to put things in perspective, the Compass algorithm used about 140 variable. And we were first very surprised to see that we could come up with a very close accuracy, like the same accuracy as they had, with just a fraction of the variable. The next thing that surprised us is that the accuracy of the model was kind of weak. So we're talking about 68% overall accuracy, but only 74% AUC, so area under the curve. And just as a comparison, we say that we actually have a model when we are above 75%. So not a strong model. Then the other surprise was to see that even though we remove races and gender, our algorithm was committing the same bias. So we try to understand why. And there might be a lot of different reasons. We don't necessarily have identified all of them, but first one could be a bias in the data itself. So we know that the police use predictive algorithm to identify neighborhoods where some crime are going to be committed. So um, if you identify some black neighborhoods, then you're going to spend more time, and obviously you're going to identify more crime and catch more bad people, so called. So that's one of the possible reasons. The other one is also the unbalanced population. So we can see that we have more African American in prison than Caucasian. So the model will better learn to identify those than the underrepresented race. And finally, and I think that one is also very important, is that if you look at, so here we have the, let's say the risk profile. So you have the percentage of people by race who um, are reoffender. So you can see that African American and Native American have a much higher risk profile than the other races. So the algorithm trying to uh, predict who is going to recommit crime is going to be more strict with the higher risk profile. But then we took the question a bit further and we tried to understand why those people have higher risk profile. So again, we don't have all the answer, but what we saw is that when you look at the variable importance of the model we built, some of the key driver are the priors count. And the priors count, and you don't see it here, but the priors count is also correlated with the juvenile count. And as you can see here, like the model is very weak. There is only like two to five key driver. And but more important, we can see that also those juvenile crime are correlated also with race. So we kind of understand that it might be something else, that there might be some more like deep rooted social and economic injustice amongst the races, and that might cause the difference, um, the difference in the risk profile. So that was not the scope, like as much as we wanted to go further in this, and we might, but for the hackathon, we decided to focus on, okay, how can we try to make a better algorithm and to reduce the bias with the bias data that we have. So as you might know, and especially with gradient boosting model and other model, like the model gives you a probability of uh, like give you for someone the probability that he's gonna recommit a crime. And with this probability that you have on the x axis, okay, so just so you can follow me, on the y-axis you have the error rate, so that's the false positive rate, and the different lines are how the error is fluctuating when you change the cutoff point for the different races. Here I just took 3 to not overcharge the diagram. So you can see that a cutoff point, okay, so let me, for those who are not familiar with this, the cutoff point is we call the cutoff point the point after which we're gonna say this person is gonna be a real offender, because the algorithm give you a probability, and then you have to decide, okay, at what point I say, or I think I have enough signal, like a strong signal that tell me that these people is gonna be a reoffender. So if you're very strict, let's say you go to 70% or 90% or more, then you're gonna be very precise in the sense that the people you're gonna predict, almost all of them are gonna reoffend the crime. But the trade-off is that you're gonna capture almost nobody. And if you have a low cutoff point, let's say 40%, you're gonna capture more reoffender, but you're gonna also commit a lot of mistake. So usually with those model, what we do is we choose one cutoff point for everyone, and that's what I call predictive parity. So the same treatment for everyone. And as you can see here, by doing so, let's say we choose 50%, since the risk profile are different, what we're gonna do is have a bias in terms of who suffer the harm of the algorithm. And it, like this, like choosing the predictive parity works well in a lot of situation, but here, with all the context that we have about bias amongst race, we try to find a way to have a parity of the outcome. So what we did is that we fixed the percentage of error for all the different races, which implies that we have now to choose a different cutoff point per races. So this in itself is questionable, because now, in order to have a parity of the outcome, you apply a different treatment to the different race. So it means like you have to identify people by their race in order to come to a parity of the outcome. So let me just be clear here. It's not a good solution. I think it's the least bad solution, because when people's lives are at stake, I think we can't afford to have such discrepancy in terms of who suffered the harm of the error. And we will need more research, in, like with philosopher, with a moral practitioner to understand what can we do in terms of ethics or what we can't. So that's what you have in front of you. And please stop me if you have question, or we can come back also later. But stop me if you have question. So what you have here is just a comparison of uh, yes. Ah, so what we have here is a comparison of the compass algorithm and what we did. So you can see that's the percentage of accuracy, and we only display two races for sake of visibility. So you can say that the choice we did here has a cost. And now we're trying to understand what's the cost that we're paying. So you can see that in terms of accuracy, it's really not bad. It's lost what 1% of accuracy, which is very good
Mm-hmm.
because we are able to reduce the bias. And here is the percentage of person being wrongly predicted as future recidivists. So that's another performance metrics that we can look at. And we can see that we at least equalized, and it's not perfect yet. We didn't have a lot of time. It's a manual process, but we're able to uh, equalize the false positive rate here. So, which means that Caucasian, we're gonna have more error for Caucasian and less for African American, but both races are gonna have almost the same error rate. Another predictive measure that's very important to look at is also the percentage of unidentified recidivists. So we can see that we let less Caucasian go while there were recidivists, and we stabilize at a 44% for both African American and Caucasian. So again, it's I think it's an improvement. Most of all, it's a trade-off. Everything is a trade-off here. And but I think that perhaps we could take another step back and ask ourselves that in a context of biased data, of like a world where there is like such a disparity in terms of juvenile crime, should we really use a weak model with biased data in order to punish and reinforce those discrimination? Or perhaps we could use the data and the algorithm, as poor as they are, to try to identify where we could heal those communities, and perhaps where we need more school or better institution, or I don't know. But that's uh, food for thought. Thank you.
Yeah. Thank you, Jonas. If you could stop sharing. Nice. Thank you. And I will reshare. And I'll now take you all through a demo of our web application Gavel 2.0. So firstly, the user is presented with a case study. So the user in this case would be the judge. So the case study is entered in the search bar. So let's use case 555, for example. So we are now taken to a page with information on case 555. On the left, we are presented with the defendant's profile, where we see the individual's name, their prior offenses, and their subsequent offenses. If we would like to see more information, we can click More Info. The functionality of this section hasn't been built yet, but we will see this page is still in progress. Please check back later. In future, this page will include historical and current information about the defendant in question, which will give the judge a sense of who this person is and what their present criminal record is like. Going back to the main page, we see two scores on the right-hand side. The first score, labeled as Compass Algorithm Score, tells the judge what score was generated from the Compass algorithm. The second score or algorithm score represents the normalized score produced by our algorithm. As we can observe in this case, our algorithm has produced a lower score. Our hope is to ensure that the judge is cognizant of the current biases and errors associated with these algorithms and to gain more insight into the case studies presented. So, why our score? As mentioned earlier, the COMPAS algorithm is known for producing biased results by race. Therefore, we present the judge with an opportunity to view the error rates directly according to race. On the left side, we have 6 options. Choosing one of these options generates the corresponding error rates produced by the COMPAS algorithm scores versus all algorithm scores. Suppose a judge chooses the first option, African Americans. On the right, we observe almost a whopping 10% difference in the error rates, where our error rate is substantially lower than that of COMPAS. Underneath these scores, a judge can choose to learn more by viewing a preview of our fact sheet, or go back to the initial page and search another case study by clicking Go back to the case ID screen. If the judge chooses to view the fact sheet, he or she will view 2 sections. On the left, we provide a brief description of the aims of Gavel 2.0, an explanation of the error rates we observe, a comparison of accuracy between the algorithms, and a final statement. On the right side of the fact sheet, the judge can observe general statistics regarding algorithms used for predicting recidivism. In future, we plan to add more information on data visualization to this fact sheet. Thank you. So, Irfan, you can
Uh,
take it away.
Thanks, Jad. Now coming to our future work. For future work on this project, or rather addressing this issue, we decided that we'll start growing an online community for those who have been impacted by these biases in the criminal justice system. Our aim is to create a social impact startup and movement which sheds light on the seriousness of the current matter and echo the cries of real people who had their lives or the lives of their loved ones disrupted without good reason. Complementing this, we will conduct sentiment analysis on the testimonies we have received in an attempt to highlight the impact on these communities using a data driven approach. We wish to spread awareness by unearthing the creators of the Compass algorithm by creating a community of supporters who are not afraid to speak out about the biased algorithm. Let us urge the creators of the Compass and by the extension the world to reassess how we use artificial intelligence and ensure that the world is made cognizant of the concept of data ethics and its relevance and importance today. We are still exploring the best ways to make an impact.
Thank you, Irfan. All in all, our goals are to 1. Provide the judge with supplementary information so that a more informed and fair decision can be made. 2. Provide support and help bring justice to our BIPOC, LGBTQ, and other marginalized communities, as well as other individuals who are treated unfairly. 3. Direct accountability back to the judge through the use of explainable AI. We hope that this presentation can serve as a peek into the future of Gavel 2.0 and pique your interest into the potential impact it can bring to our justice system. Thank you all for lending your time and patience to us today. We are grateful for the opportunity given to present our work. If anyone else has any ideas, questions, or suggestions, we would really welcome them. Please feel free to share them with us. Thank you.
Okay, well, thanks, thanks, Jade, Aisha, Jonas, Irfan. Very interesting talk. I mean, I've read about this bias before, but it's nice to see it in detail.
Thank you.
I just have a couple questions. So essentially, what you did is for your algorithm, you equated the false positive rate for each race, right? And that's basically the way you kind of resolve the issue. Is that roughly what you did? You used the different thresholds so that the false positive rate was the same for different races, right?
Yes.
Okay.
Yes.
Yeah. So one thing I'm always curious about, I mean, so you have these two types of errors, false positive, false negatives, but the damage or the cost of incurring them are slightly different, right? And right now, typically we treat them as being equal in value, but a false positive error compared to a false negative error, you know, it has different costs. Were you able to kind of estimate what the difference in cost is between these two types of errors? Because you can now use that to kind of weight things a little bit differently, right? You would want to focus on reducing the more costly errors than the less costly errors, even if the overall accuracy decreases. Does that make sense?
Yeah, I think it makes sense, and so like in terms of the cost of false positive or false negative, so it's basically the cost of putting someone like accusing someone of being a recidivist when he's not. So that's gonna impact his life because he's perhaps not gonna be able to leave prison.
Right.
And the other one is you're gonna let someone like in a society that could harm the society. So I think it's like it's not a question I would say I have the answer because it's a very difficult one, and we can't translate it in numbers as we can often do for other problem and issue we have. I would say that we could at least separate the because there is the recidivism, and there is also like the violent crime recidivism. So I would say that for the violent crime, um, we could say that perhaps the cost of false positive, the cost of false negative, so letting someone go out in the society might be bigger, but fortunately, like it's a very difficult one, and it's also like why I think before putting something like this in production, we will need a lot more discussion with practitioner, with also like philosopher or moral professional, etc. But yeah, it's a very good question.
Yeah, no, and I agree with you. It's hard to quantify these things. I mean, both are bad, but I guess you need a lot more data to really kind of quantify whether one is 5 times more in some kind of overall social cost than the other one. But very interesting. Thanks.
And perhaps also like being able to differentiate the type of crime. So that will be like a big one, because I assume that in those high risk profile, there might be a lot of not sure about the term, but like of and I don't know if we can say that, but low crime, like non-violent crime, that could be due to also like people being in need or people trying to say help with the work they have. So yeah, I'll go that road first. Thank you for the question.
Thanks for the answer. Thanks.
Okay, I have a question. Hi, welcome again to Trinidad and Tobago. If Patrick ended on a quantifying question, I have a qualifying question. Jade, can you go back to the first slide, the title slide?
Sure. Let me go back. This one?
Okay, all right. Okay, thanks. So when Jade ended, she said, our criminal justice system. But Jade is not in America, right? So while you all are a global team, what you've presented is based on American data. So I like that towards the end, I believe I believe it was Jonas, you mentioned the bias may not only be in the algorithm, but the data itself, because for such a global team to be relying on American data, do you think they're, sure, if you're dealing with the American criminal justice system, but if one were studying race at a global level, where would one get this kind of data? I mean, just generally, I'm pushing towards the concept of data colonialism, meaning we all tend to just end up working with data from the US. Ethically, any one of you, how do you feel about that? That the US tends to be the ultimate well for all of our data. Very US centric. Any of you could take that question.
So if I can just perhaps like start, and then I'm gonna let my teammates continue. Like first, it was I would say that the predictive policing is, and like AI in the criminal justice, it's not there yet in Switzerland first. So I think it's something that very present in the US.
Yeah.
That would be one point. Then another one was that, and I think you're right, like we have more data about the US, we talk more about the US, and it's also why we were able to find data quickly in this 48 hours
Yeah,
hackathon
hackathon.
in order to actually come up with something. Also, another point, actually, I forgot my last point, but I don't know if you have other comments, Jade.
I agree 100% though. With this kind of topic, for one, with the Compass case, Compass is, I believe, US based.
Mhm. Yeah,
Yeah.
and another like something that's, so it will be very interesting to do, and but it will also take a lot of time to, like, if you want to have if you want to have like a worldwide view of the criminal justice system, then it will need a lot of effort in order to collect the data, to standardize it. And I'm not saying that we should not do it. I think we should. But yeah, with the time constraint, it was the choice that we did.
Okay, so at the time, go ahead. I mean, well, at the time it was a time constraint. Very good work, obviously. But as you move towards next generation and other versions, as globally as you all are, I hope that kind of diversity will be reflected in your data.
Right.
Yeah, it's a very good point, and I think we can add it to the list. And it's also why we're here today. I think it's to have feedback like this, and that we should do a list of first like country that practice like that use AI in the criminal justice system, and then try to find some data and also like bring some perspective and comparison between the different places in the world.
Yeah, so I think in the first case as well, because Compass would have used US data, we would have wanted to use similar as demographic as possible to kind of keep it, since we directly compared our algorithm to theirs, we would have liked to keep it as close as possible.
Yes,
I
and
would
you
also
all,
like to add something.
yes, go ahead.
Sure.
So I'm really grateful for the question that you asked, because as you rightly mentioned, we're a very international team, and we're a team that also consists of people who are people of color. Me myself, I'm originally from Africa, so I'm really a strong proponent of a post-colonial perspective. So the reason why we chose this case was because first, it was a prominent case. Secondly, we found that it was the best way to really highlight these injustices that are happening. Of course, you can find these risk assessment algorithms not only in the US, but also in other different countries. So what we hope to do in the future, maybe as you noticed when you looked at the way Jonas was presenting the data, we didn't actually follow the typical way that data is visualized. We didn't normally, when you look at data, the way it's visualized, it kind of conforms to a kind of colonial mindset. So you will always find the word Caucasian as the number one, and then you'll find all the other ones following. But if you look at the way Jonas presented the data, he never actually started with Caucasian, and he didn't use the typical colors that are used to associate the different races. So we try to kind of incorporate it in a way in how we present our data. So this is something that we want to do also in the future, to do racial equity awareness in our data visualization. So the Compass case, yes, if we look at data colonialism, why do we use the West as the starting point of, or the US, who is seen as a superpower, as like the starting point of our discussion? We wanted to really show how, or capture how these data relations can unfold and how we can make a natural conversion of life in a data stream. So, and to show also unknown opportunities for social transformation and behavior change.
Okay, thank you for the responses. Any other comment? Because basically, you guys won. You guys came first. So I know that you can do everything that you intend to do with the next versions of your results. Okay, so best of luck.
Thank you.
Thank you.
Thanks for the question.
Yeah, I have one other question. I know you focus on bias in race, which is great, but did you find any other features that are biased as well, like income level?
So we didn't have access to this data, but I believe Compass, well, the one that developed Compass had access to it, because it's like they have 140 data points, but we just had a very limited set of data.
Okay.
And I believe that would be highly correlated with crime, as you said.
Yeah.
So yeah, I think that's one of the issue too. Yeah.
Okay, so let's thank Jade, Aisha too, Efran and Jonas for the presentation, the joint presentation. Thanks a lot, guys.
Yeah, thanks again. And yeah, especially for staying up so late. Present. Thank you very much. We appreciate it.